Okay, this is practice set number 2. Math 100 practice set number 2. The first problem is determine the domain of continuity for the function. So this is number 1 for the function f of x. That is x squared minus x minus 2 over x minus 3 if x is less than 2. But it will be 0 if x is equal to 2. And it will be square root of x plus 1 if x happens to be greater than 2. So determine the domain of continuity. So in other words, you can just assume that it's all real, but find the discontinuity. Now there are 3 rules, basically. Number 1, any denominator, anything that will make the denominator 0, you have to exclude. Exclude any x that will make the denominator 0. And number 2, exclude anything in the square root, or the radicand, anything that will make the radicand 0. Exclude those that will make square root negative, okay? I mean inside negative, because we know that square root cannot take negative numbers, so exclude those numbers that will make any radicand negative. Or you can say that keep those things, the domain will be all those that are positive, that will make the radicand positive. Number 3 are things to do trig functions, or long functions, log functions. For example, log of any number, that x cannot be negative, so x has to be strictly positive. So, or log of x, so x has to be strictly positive. Now, if it was anything other than that, for example, if you happen to have log of x squared plus 1, let's say, then you have to say, well, x squared plus 1 has to be greater than 0 as a starting point for finding the domain. That is, assuming you have something like that. Or, for example, if you have log of 1 over x minus 1, well, then you say 1 over x minus 1 has to be greater than 0, and that's your starting point. Of course, here's a denominator, so the first rule applies, that is x cannot be 0. Oh, sorry, the denominator cannot be 0, so x cannot be 1. And then secondly, you have to solve this. When you solve inequality, in this case, you flip both sides upside down. Well, you cannot. So basically, if this is positive, then this will have to be positive. Okay, so x minus 1 will have to be positive, then the whole thing will be positive. Of course, if this was negative, then 1 over negative number would be negative. So x minus 1 is going to be greater than 0. Then x is greater than 1. So, and of course, that will take care of that already. Anyways, digress a little bit. So, in this question, we just have to make sure that nothing in the denominator will be 0, so that would exclude 3. However, let's just do part A first. If x is less than 2, f of x is simply x squared minus x minus 2 over x minus 3, which you can factor as x minus 3, x plus 1, x minus 2, and x plus 1 all over x minus 3. So in this case, you can say that x cannot be 3. However, if x is less than 2, it will never be 3 anyways. So nothing wrong here. So in this case, nothing will make f of x undefined. So x less than 2 will not include this x not equal to 3 anyway. So everything will be continuous. Therefore, f of x is continuous for any x less than 2. Okay, well, let's find out. If x equals to 2. Well, if x is equal to continuity, means that the limit as x goes to 2 from the negative side of the function must equal the limit as x approaches 2 from the positive side of the function, and equal to f of 2 as defined at 2 as well. So these 3 must equal in order to be continuous at x equals to 2. So let's find out. If x is exactly 2, according to this, it should be 0. According to this, if you are approaching 2 from the negative side, that means x has to be less than 2, then you have to use this formula, which means the function you're looking at as x approaches 2 negative has to be this one. That is x squared minus x minus 2 over x minus 3. And we want to know if that is equal to this limit, the limit as x approaches 2 from the positive side. If x approaches 2 from the positive side, you have to use this one, which means you have to use root x plus 1. So when we factor this, like before, we were able to show x minus 2, x plus 1 over x minus 3. If the limit as 2 approaches 2 from the negative side, so in that case, this will become 0, basically, and this will become 3, negative. So anyway, 0 times anything will be 0. So this will be 0, no problem. And then now we want to know what this is when it's approaching 2 from the positive side. When it approaches 2 from the positive side, so such as 2.1 or 2.01, 2.001. So this is simply 2 plus 1 or root 3. So the limit don't agree because the left-hand limit does not equal the right-hand limit. The left-hand limit does not equal the right-hand limit. Therefore, the limit doesn't exist. Therefore, it's discontinuous because these two don't agree and these two don't agree. So discontinuous at x equals to 2. Okay, now what if x is greater than 2? If x is greater than 2, you like square root x plus 1. Is there any way, what's the domain that is only if it was the radicand inside the square root got to be greater than or equal to 0, which means x has to be greater than or equal to negative 1. So if x is greater than or equal to negative 1, anything in the domain would be positive. But this is already greater than 2. So anything greater than 2 will already be greater than negative 1. So therefore, nothing will make this one illegitimate. And therefore, the function x plus 1 is continuous for all x greater than 2. Okay? Therefore, the domain of continuity, that means tell me where all the x's where the function will be continuous. Therefore, in this case, will be continuous for all x less than 2, greater than 2, but not at 2. So that is, x does not equal to 2, but x is a real number, is fine. So this is domain of continuity. Obviously, if you graph this, it should look somewhat like this function separately, and at 2. I know the graph of that one looks somewhat like that, you know, line down parabola. But when x is at 2, it's all of a sudden down to 0. And here's a hole. And then this function, which is really this function, which had supposedly a vertical asymptote at 3, but we can't draw 3. But when it is 2, this function actually gives you 0. So it does reach that point. However, it probably looks somewhat like this. Okay, but anyway, there's a gap. And therefore, this is discontinuous at x equals to 2. That's how you answer this question. Okay, next one. For each of the following functions, determine the corresponding domain of continuity. So 2a. So what is the domain? Let's say e to the sine of x. Well, the function e to the anything is continuous throughout any x that you can come up with. So now, because e to the x, domain of e to the x is all real, and sine of x, doesn't matter what x is limited between 1 and negative 1, but that is any real anyways. So you can plug any angle in sine x, you'll get a number, and that number is accepted by e to the x. So therefore there's no restriction. In other words, there's no denominator, there's no square roots, there's no function where you're not allowed to use some values. Therefore this is the domain of continuity is all real. And part B is square root of 3 minus x squared. So in this case, 3 minus x squared must be greater than or equal to 0. And therefore 3 must be greater than or equal to x squared if you bring this over. And then take a square root of both sides. So root 3 is greater than or equal to absolute value of x. Now that means root 3 is either greater than or equal to x and greater than or equal to negative root 3. Okay? So that's how you write it. Now you cannot write, in this case, you cannot write root 3 is greater than or equal to, or cannot equal to plus or minus root 3. Okay? You cannot do that because you know, when you take a square root of x squared, it has to be absolute value of x. So you cannot write it like plus or minus number 3 and greater than or equal to x. So that's wrong. And keep in mind that when you're dealing with inequalities, for example, if you have moved the 3 over to the right hand side, then you end up with this. Now, if you drop the negative sign, you cannot keep the inequality the same way as it is, because every time you drop the inequality or multiply or divide both sides by negative, like in this case I multiply both sides by negative 1, I will get rid of the negative sign. But every time you multiply or divide by negative, you have to reverse the inequality. Okay? So now you take a square root on both sides, you have the absolute value of x, and that will be root 3. The positive root 3, not plus or minus root 3. That's the same as writing this anyways, except it is in proper order. From negative root 3, less than or equal to x, less than or equal to 3, rather than root 3 greater than or equal to x, but the two are the same. So the domain of this one will simply be this, where x is all real numbers, limited by within that range. Part C, root of 1 plus x over x minus 2. So in this question, you have both the denominator and square root. So I would say x minus 2 cannot be 0. That's when you have the denominator. So x cannot be 2. And then you have root of 1 plus x got to be greater than or equal to 0. Okay? Which means, move this over, x is greater than or equal to negative 1. So if you look at the number line, anything x is greater than or equal to negative 1. So here's negative 1, solid dot. Here's a 0. And anything greater than that is supposed to be the answer. However, you cannot include 2. So at 2, you have to put a hole here. Now, one way to express that as a domain, you say domain of continuity will be a set of all x's such that x is greater than or equal to, we use on the dot, negative 1, x cannot be 2, and x is all real. So that's one way of expressing your domain. So problem number 3 is evaluate the following limits. So we have, we have 6 limits to evaluate. So A is, what is the limit as x approaches negative infinity of arctangent e to the x? It's negative infinity. Okay, so in this case, you can actually do this. move the limit inside the inner function first. So arctangent limit as x approaches negative infinity, e to x. Do that first. But that one is same as e to negative infinity if you plug it in, but that is same as 1 over e to the positive infinity, which is 1 over infinity, or just 0. So in other words, now you end up with what is arctangent 0. So what angle the tangent gives you 0? So tangent x equal to 0. So what is the x? If you recall, tangent function somewhat looks like this at pi and negative pi by 2 and negative pi by 2. So 0 is only at 0. So theoretically, you say 0, however, because inverse tangent it repeats itself with a period of pi. So theoretically, it's supposed to be 0 plus or minus n pi, where n is just any integer, positive or negative, meaning that any period of pi away will also give you the angle which tangent of which will give you 0. So unless you're dealing with strictly the function that is has a limited domain, in that case your answer will just be 0 without mentioning anything else. Okay, so that's A. B is limit as x approaches positive infinity, e to negative x sine x. So again, you can do this one separately. Positive infinity e to negative x times limit x goes to positive infinity sine x. Now, e to positive infinity will become e to negative infinity, like because x is going to infinity. So this becomes e to negative infinity, which we said before was 0. And then this sine function, where the angle goes to infinity, well, this number is called bounded by 1. That is, the absolute value of that is always between 1 and negative 1. So we can say this is bounded by 1. Or you can say the value, whatever the value is k, and this number is 0. 0 times the number, which is always fixed or less than 1, will be 0. Okay, 0 times any fixed number will be 0. Or you can say that the answer here is sandwiched between e to the negative infinity times 1 and greater than e to negative infinity times negative 1. But e to negative infinity times 0, negative 1 is 0. And that is 0 times 1 is still 0, so sandwich between the two will have to be 0 too. So that's how you deal with, when you encounter limit of sine where the angle is infinity, it's bounded by plus or minus 1. But this one is going to 0, so 0 times anything bounded, doesn't matter if it's 1 or negative 1 or 1 million to a negative million, so long as it's bounded, 0 times that will be 0. So the answer here is 0. So we're doing C now. C is limit as x approaches infinity, x plus 1 over 4th root of x cubed minus x plus 1. Now, when you take a first glance, you need to get a sense of which one of the numerator or denominator the exponent or their power are equal to as x goes to infinity. So in this case, when x goes to infinity, anything that's less than x on the top drops out. That's too small compared to x. For example, if x is 1 trillion, 1 trillion plus 1 is negligible. So the top is roughly like x. And the bottom, well, the minus x plus 1 will disappear compared to x cubed. So you basically only have x cubed at the bottom, but is raised to the is the 4th root of x cubed. Now the point is, when x goes to infinity, you will want to get a sense of what the whole thing will look like. So the top will look like x, the bottom will look like 4th root of x cubed, which you simplify is basically 1 up here, and this is x to the 3/4. So this becomes x to the 1 minus 3/4, or just 1/4 on top. But if x goes to infinity, and this whole thing will go to infinity too. So you get an idea now that the answer is probably infinity. So the way we go about proving that then is to make the denominator 1, and then we will see or show, therefore, that whatever on top left over will go to infinity. So the way we then go about doing this is find the highest degree at the bottom, which we know is x to the 3/4. Okay. So what we then do is, for example, divide everything in here by x cubed. Okay. Divide everything in here by x cubed. But when you do so, you need to multiply outside by x cubed as well. That is 4th root of x cubed. Okay? Then you are not changing the question. So inside the 4th root, I divide everything by x cubed, but I have to remember multiply x cubed with the 4th root outside, so that you're not changing the question, and the top is still the same. However, if you rewrite this, this one can now go to the top as if it was x to the negative 3/4. Right? So if you multiply them in, then you get x to the 1/4 plus x to the negative 3/4. Alright, so which is same as 1 over x to the 3/4, all over 4th root. This is now 1 minus 1 over x squared plus 1 over x cubed. Now then, we're ready to take a limit as x goes to infinity, because basically, when x goes to infinity, 1 over infinity is 0, 1 over x cubed is 0, 1 over x to the 3/4 is also 0. So, but this one is now infinity. So that is same as x goes to infinity of x to the 1/4 over 1, right? But this is clearly goes to infinity. So the answer is just infinity. Part D is what's the limit as x goes to negative infinity of cosine 1 over x. Okay, well, you can say this is same as cosine of limit as x goes to negative infinity of 1 over x. But cosine of limit of 1 over x when x goes to negative infinity is supposed to be 0. Although it's a negative 0, but it's basically 0. Cosine 0 is 1. So the answer is just 1. E is limit as x goes to positive infinity of sine of x. Now here's a problem. This is undefined or do not exist because x sine is oscillating. It doesn't matter what x is approaching in infinity. This will oscillate between 1 and negative 1, and there's no single number that will stabilize 2. So there is no answer. It's not infinity, it's not negative infinity, it's not 0, it's not 1, it's not negative 1, it just do not exist because it oscillates between negative 1 and 1. So f is limit as x approaches negative infinity of x squared minus 3x. Well, obviously, when x goes infinity, this would cannot compare to this. So you can say that when x goes to infinity, some people do it this way, that is, divide everything by the highest degree. So, but actually in this case, it's if x goes to infinity, this cannot compare to x squared. So, or you can just factor out, say, x squared. You have 1 minus 3 over x, like so. When x goes to infinity, this becomes limit as x goes to negative infinity of x squared times limit as x goes to negative infinity of 1 minus 3 over x. But 1 minus 3 over x is just 1. Right? So limit of 1 minus 3 over x, and when x goes to infinity is just 1. But then, when x goes to negative infinity of x squared, well, that is actually positive infinity times 1. So the answer is just positive infinity. Anything squared is positive. So that's how that works. So we do G, which is limit as x approaches infinity of square root of 4x squared plus 5x plus 7 minus 2x. Now, effectively, these 5x plus 7 can be ignored when x goes to infinity, and then you have root of 4x squared, which is 2x, minus 2x, so the answer should be about 0. But the way to prove that is when you take a square root like this, okay, you can use conjugates to replace the roots. Because if you actually go ahead and do that, you'll get infinity minus infinity. Well, some people say that as 0, but that's not always the case. So, infinity minus infinity means the same thing as 0 over 0, is that you need to factor out something or delete something, because the answer is undefined. If you just get infinity minus infinity, that does not mean 0. So what you need to do is multiply top and bottom by the conjugate of that. So root of 4x squared plus 5x plus 7 multiplied by the conjugate, which is root of the same thing plus 2x, root of that plus 2x. But then on the top, you then have, without the square root now, 4x squared plus 5x plus 7, but now minus 4x squared, okay? And then the bottom will be that plus 2x. That is just whatever is in here. Now you can see that the top 4x squared cancel 4x squared. You just have 5x plus 7 all over root of 4x squared plus 5x plus 7 plus 2x. Now remember, limit is x goes to infinity. So if you go x goes to infinity now, you don't have infinity minus infinity problem anymore. But you kind of have these x and these 4x squared and x here. So what you do is you divide the top and the bottom both by x, like so. So 5 divided by x is just 5. But 7 divided by x remains 7 over x. And 2 divided by x is just 2. And when this one divided by x, you're actually dividing by x squared inside the square root, not just a single x, because once you are inside the square root, whatever you multiply outside becomes squared inside the square root. So this becomes something like 4x squared over x squared plus 5x over x squared plus 7 over x squared. Obviously, these two simplify, and x simplify with a single x. Now then, we are ready to take our limit. So our limit as x goes to infinity, on the top is just 5 plus 0, okay? And then this becomes square root of 4 plus 0 plus 0, right? And then plus 2. So you have 5 over 2 plus 2 is 4. So the answer is 5/4. Then we have problem 5. Is that show the equation e to the x minus 2 cosine x is equal to 0 has at least one real solution. Has at least one real solution. Now every time you see questions with at least one real solution, that should remind you of intermediate value theorem. Because that's what intermediate value theorem mentions, that there must be at least one something in between two values. So intermediate value theorem simply says if you have a continuous function in an interval, let's say, okay, so in problem 5, they want you to show that this equation e to the x minus 2 cosine x equal to 0 has at least one real solution. anytime you see the word at least one real solution, should remind you of the intermediate value theorem, which says in the interval a, b, if there is a continuous function, whatever that is, if on one end, let's say at the a end, or the f of a, and on the b end, f of b, if one is above the x-axis, which means, say, positive, and the other one is negative, then somewhere between a and b, the function must cross 0. That is, f of some number, c, that its value at c, the function is 0. So that's intermediate value theorem. So what we need to do then is to show that I have a number a and b that I could find, where at a, this function, let's call it f of x, is positive, and at another end, b, if I could find the b, where f of b is negative. Well, we know that e to the x is an exponential function somewhat like this, and cosine, however, is somewhat function like this. But if e to the x is going to subtract that, I will see that if x is quite large, e to the x is bound to be bigger than 2 to the minus 2 cosine x. So if I find something like 100, I'm sure that e to the x is larger than 2 cosine x, therefore positive. All right? And whereas if I find a number, say negative 100, e to negative 100 is a very small number. But cosine of some number, it could be negative, could be 0, so let's make it easier. Let's say negative 100 pi. Well, we know that any even number of pi, cosine is either going to be positive 1 or negative 1. So in this case, I chose exactly multiples of 2 pi, 100, negative. Cosine will be actually equal to 1. If cosine negative 100 pi is 1, whereas e to that is very small, then e to the small number, this small number minus negative 2 is going to be negative. And therefore, I can now choose, say, let a equal to negative 100 pi, and then you plug it in. You say f of a is e to negative 100 pi minus 2 cosine 100 pi. But we know that this is e to negative 100 pi minus 2 times 1. Okay? Negative 100 pi, cosine negative 100 pi is actually 1. So it's e to the negative 100 pi minus 2. Now whatever that number is, if you punch it in the calculator, it turns out to be a very small number. This number is very small, minus 2 is actually, negative. Okay? Now you don't really need to know exactly what that number is, but that would be a very small positive number. Minus 2 would be negative. And then we say let b is 100. Then f of b is going to be e to the 100 minus 2 cosine, well, let's see. 100 is not such a number because cosine 100, you don't know what it is. Whereas here, I want it to be 0, it would be easier. So how about let's just say pi over 2. Okay? So e to the pi over 2 minus 2 cosine pi over 2, but cosine pi over 2 is 0. And e to the pi over 2, whatever that is not going to be negative, and it's positive. So this is positive. So we have just found a number a, which is negative 100 pi, and number b, which is just pi over 2, where f of a, this number, is negative, below the x-axis. And at b, f of b is actually positive, somewhere up here. Therefore, you say by intermediate value theorem, okay, then you can say that there must exist a number. So therefore, you say by intermediate value theorem, there exists